Hello class and welcome to another exciting facilitation for this semester. I am Dr. Annie George, Department of Public Health, Faculty of Health Sciences, and will be your guide. Hope we'll all enjoy it. Thank you. So welcome to our last class on topic 8, measures of dispersion. In the previous class, we discussed measures of central tendency as one of those measures you use in descriptive statistics. So our last lecture is going to be on measures of dispersion. So let's see what measures of dispersion are. At the end of the lesson, we should understand that standard deviation, range, variance, and coefficient of variation are measures of dispersion, and see how we can calculate standard deviation, range, and variance. So, measures of dispersion. What do we understand by measures of dispersion? It shows how spread data are from the center from each other. So if you have an array of numbers, how far are these numbers from one another and from the center? How variable are the data from the center? How scattered are the values in the distribution? So this measure of how scattered values are include standard deviation, range, variance, and coefficient of variation. These are what we use to measure dispersion, or how variable or how scattered values are from the center. So we'll start with standard deviation. It's one of the most important measure of dispersion and the commonest. It's also the very useful one that is very sensitive to outliers. It involves all observation in the distribution and is usually the square root of variance. Mathematically, it is very, very manageable with simple formula. So here we are, the formula for standard deviation. Standard deviation is the square root of the summation of the frequency and the mean deviation squared over n minus 1. That is this formula for standard deviation. So let's go back to calculating the mean from our frequency distribution table. Remember, serial number 1 to 5, our class still remains 5 classes, 40 to 49 and down to 80 to 89. And then we now calculate what we call the class center, which is x. 40 plus 49 divided by 2 will give you 44.5. So you add the lower class and the upper class and divide by 2. That's the average. That will give you the class center, which is x. So you have 50 plus 59 divided by 2 will give you 54.5. And down to 80 plus 89 divided by 2 will give you 84.5. So of course the frequency still remains the same, 5, 17, 13, 13, 2. And the total number of frequencies is 50. And then the class center x times the frequency will give you fx, which is 222.5 for number 1 and 926.5 for number 2, down to 169 for number 5. The summation of fx will give you 3000, 125. The formula for calculating the mean is sigma fx over n. Of course, sigma fx, which is the summation, is 3125 divided by the total frequency over 50 will give us 62.5. So the mean falls between class 60 to 69. So our working mean or assumed mean is 62.5. So we look at this table for finding standard deviation. If you look at this table, we have our class mean, our assumed mean as 62.5. Down the class, you could see the mean, the assumed mean is equal to 62.5 from our previous calculation. Then we'll have the class center, which is x. We have the frequency total, which is 50, and we have fx. Now we have the mean deviation. The mean deviation is calculated, which is x minus assumed mean. If our class center x is 44.5, minus it from the assumed mean, which is 62.5, you have minus 18. If you go to the next class, 54.5 minus 60 from 62.5 will give us minus 8. 64.5 minus 62.5 will give us 2. Down to 84.5 minus 62.5 will give us 22. So if you square the mean deviation, minus 18 squared is 324, minus 8 squared is 64, down to minus 22, down to 22 squared will give us 484. And then this mean deviation squared multiplied by frequency will give you the frequency multiplied by mean deviation squared, which is the last column, 1620. That is 324 multiplied by 5 will give you 1620. 64 multiplied by 17 will give you 1088. Down to 484 multiplied by 2 will give you 968. Summation of that frequency multiplied by mean deviation squared will give you 5600. In the next slide, we will have an activity. Let's see what it is like. So activity 1, find the standard deviation using the formula as stated. So applying the formula for standard deviation, standard deviation is equal to the square root of the summation of the frequency multiplied by the square mean deviation squared over n minus 1. So applying it, remember in the previous table we calculated the summation of the frequency and the mean deviation squared to be 5600. Our frequency is 50 total, so n minus 1 is 50 minus 1, that will give us 49. So if the standard deviation will now be the square root of the summation of the frequency and the mean deviation squared, which is 5600, square root of 5600 over 49, and that will give us 10.69 as our standard deviation. So we'll move to the range as another measure of dispersion, another measure of variability, another measure of scatter of data, of values. So the range is the normal limit of biological characteristics, the limits, the lower limit, upper limits of biological characteristics. Observations fall usually within 95% confidence limits. When you subtract the smallest value from the largest value, you get the range. So from our distribution table, the frequency table, our smallest value there is 40 in the class, and then largest value is 89. So when you remove 40 from 89, you have 49. So our range is 49 in that distribution table. In the next slide, we'll have another activity. Let's see. So activity 2, which is calculate variance. Variance is the third measure of dispersion, which we're actually learning how to calculate. Standard deviation is the square root of variance. If you square both sides, that's remove the square root on variance. So you have standard deviation squared is equal to variance. So let's see how to calculate variance. So applying the formula for variance, variance is equal to standard deviation squared. Our standard deviation, remember from our previous slide, is 10.69. So 10.69 squared is variance, which is equal to 114.29. That is our variance, 114.29. So we've learned that standard deviation, range, variance, and coefficient of variation are measures of dispersion. And we'll focus on how to calculate specifically standard deviation, which is the most important and the best measure of dispersion, as well as the range and variance. Thank you so much for listening.